Okay, welcome back, folks. So we're going to look at the second lesson in systems of equations about modeling and solving. So sometimes you're just going to be given a situation, not provided with a system, and you're going to have to build that system from the information that you're given. Okay, this is one of the hardest parts about this unit, taking that word problem, that application, turning it into an equation that you could actually deal with. So an important part of math is being able to translate different scenarios into equations and systems that we can solve. Now, it's important to remember to define your variables. If you're using things like x and y, but you don't ever tell the reader what those things actually represent, it's very hard to distinguish between what x is and what y is. Okay, you're going to create two equations using those variables because remember, a system has two equations and two variables. There's usually going to be two pieces of information that helps you relate those variables together. So if we take a look at the first one, it is telling us that the perimeter of a Nunavut flag is 16 feet. Its length is 2 feet longer than its width. Okay, create a system to represent this scenario. Now, if it's a flag, that shape is a rectangle. The perimeter of a rectangle is 2 length plus 2w, 2 lengths plus 2 widths. That has to be equal to that 16. So let's define some variables first. We're going to say that L is the length and W is the width. Okay, that means for our first equation, now I do this, I like to number the equations, equation 1, equation 2. You don't have to, other teachers might do it differently. I just like to number them to keep things organized. So the first equation, we're going to say that if I take 2 times whatever the length is, plus 2 times whatever the width is, that should be equal to our perimeter of 16, since this shape's a rectangle. Okay, now we can use the second piece of information provided to us to talk about the other equation. So the length is 2 feet longer than whatever the width is. The important word for systems of equations, the word is. Okay, that word usually tells you where your equal sign is going to go. So if you read this, and we'll build the equation as we read it. So length is, okay, length is, length equals 2 feet longer than the width. So whatever the width is, I need 2 more. So the width plus 2. Okay, so the length is 2 feet longer than the width. Okay, there's my second equation. So this would be a system of equations, 2 different equations with the common variables of length and width to represent this scenario. Okay, for part B, Denise determined that the Nunavut flag is 5 feet long, 3 feet wide. Okay, use the system above to verify that she's right. So we talked about verifying in our first lesson. I have the length, I have the width. Let's plug them into these equations and see if they work. So for equation 1, this means we're going to do 2 times our length of 5 plus 2 times our length of 3, and that should be 16. So 10 plus 6 equals 16. Yes, the first equation works. Okay, but remember, we do have to check both of them. So for equation 2, the length, which we're saying is 5, should be equal to the width plus 2 more. So 5 equals 5. This one works also. So yes, our answer is verified. These dimensions are the ones that represent this situation. Okay, the second example, the stage at the Lyle Victor Center is rectangular. The perimeter is 158 feet. Okay, so I'm just going to highlight that rectangle perimeter. The width is 31 feet less than the length. Create a system to represent this. Again, we've got a rectangle. Again, we've got perimeter. So let's define some variables again. Let's use L for length and W for width. Okay, first equation we'll do with the perimeter. So again, just like before, 2 lengths plus 2 widths equals our perimeter of 158. Okay, that takes care of the first one. Second one, so a little bit more tricky to think about. So the width of the stage is, now again, there's that word is. So width is 31 feet less than the length. Okay, the width is 31 feet less than the length. So whatever the length is, you could minus 31. The other way you could write this, which I believe is how it is in your answer key for your notes, the length could also be equal to the 31 more than the width. You could change the wording. Either one is fine. Okay, they both represent the same thing. You could add 31 to both sides, so however you choose to work with that sentence in your brain. Okay, part B then, SEBI has determined the stage is 55 feet long, 24 feet wide. Use the system from above to verify that it's right. So we don't really know if our system is right so far. So let's go to verify it. So if our verification step didn't work out, then you would know one of your equations needed a little bit of work to make it actually a true statement. So equation 1 then, we'll check that. So 2 times the length is 55 plus 2 times the width is 24 equals 158. So let's put all that in. So 2 times 55 plus 2 times 24, that has to equal 158, which it does. So 158 equals 158. That part checks out. So equation 2 then, the width, actually, the width is 24. So 24 needs to equal 55 minus 31. Okay. And it looks like we're good. That part checks out also. If you're not sure in your math, just use that calculator, totally fine. I still get my 24. So it does work in both equations. We know we're right. Okay, let's flip it over. In Calgary, school raised $195 by collecting 3,000 items for recycling. School received 5 cents for each pop can, 20 cents for each large plastic bottle. Create a system to represent this. Okay. There's going to be 2 different types of things that the school collected. They either collected pop cans or they collected large plastic bottles. Those are the 2 items. So if I use some variables like X and Y, you can use whatever letters you want. Let's make X the pop cans and Y will be the bottles. Okay. They collected a total number of physical items. So that 3,000 has to be the sum of the 2 types of items they've collected. Okay, if I take all the pop cans, all the bottles, add them together, I should have 3,000 items in total. Okay, the second equation is going to come from all of the money, how much these things are actually worth. So they got 5 cents for each pop can. So if you think about it in terms of money, they got 5 cents, which is 0.05 as a dollar amount, because they're raising a certain amount of dollars. Now, if that's 5 cents and I put this in as 5x, that's telling me it's $5 per pop can, which isn't true. So I need to make sure I have the right decimals for cents when I'm dealing with money. Okay, so 5 cents per pop can, 20 cents per bottle, so plus 0.20, that's going to be Y. In total, that is $195. Okay, so we wrote everything in terms of dollars. Now, if you wrote everything in terms of cents, if you had 5x plus 20y, you'd have to change this into 195,000, I believe. Oops. So $195 times 100, because there's 100 cents in each dollar, 19,500 is what this number would have to be. Okay, so just be careful on how you're setting that money equation up. Okay, part B, the school collected 2,700 pop cans, 300 bottles. Verify these answers. So here's our system. We'll check if this works. So for equation 1, we said that the pop cans were X, so 2,700, plus the bottles, which is 300. That needs to equal 3,000, which it does. Okay, first equation was easy to check. But now when we go to check the second one, we need to be careful about the decimals. So 0.05 times the X value of 2,700 plus 0.2, multiply that with 300, that needs to equal 195. So if we grab our calculators, 0.05, multiply it with 2,700, that gives us 135, plus 0.2 times 300, that gives us 60. That needs to equal 195, which it absolutely does. Okay. So now we know both equations are perfect. They check out with the answer provided. We know we're right. Okay. Our system has to be correct because we verified the answer into both of them. Okay. One more on here. A store sells wheels for roller skates in packs of 4 and wheels for inline skates in packs of 8. Create a situation about wheels that could be modeled by the situation by the linear system below. Okay, so let's just define some variables first. So let's call I the number of inline skate packages, okay, and R is going to be the number of roller skate packages. Okay, they do kind of sound like the same thing. If it's a roller skate, those are the ones that have 2 wheels in front, 2 wheels behind, so the wheels kind of form a rectangle. If they're inline skates, all of the wheels are in a line, so it's the typical rollerblade type fashion. That's why they're called inline skates. Okay, so here's the scenario. Here's the variables. Now, if you wanted to come up with a situation, it doesn't have to be anything fancy. So let's say that Sarah opened a roller skate, let's call it roller rink, and bought 80 packs of wheels. In total, the packs contained 440 wheels. Okay, so here's our scenario. Now we can kind of look at it. So we bought 80 packs of wheels. So the inline skate packages plus the roller skate packages, in total that was 80. Okay, now our inline skates are going to have 4 wheels per skate. So for a set, there would be 8 wheels. And your roller skates are going to have 2 per skate. So in total, they're going to have 4. So in total, you've got 440 wheels. Because when you go, you're not going to rent just 1 skate because the people that are going to go there are going to have 2 legs. So they're going to need a skate for each. Okay. So there's just a scenario that would talk about it. So developing those systems and coming up with the equations is going to be the important part before we can go get into solving them algebraically. Because all of the ones we did so far, we basically came up with the systems, but the answers were provided for us. So in the future lessons, we're going to talk about how to do both things. Okay, define that algebraic system and get the answer along with verifying it. We're going to put all the steps together. Okay, so again, if that is an issue for you, any part of that, please make sure you're letting your teacher know. We'll be more than happy to help, and we'll see you next time.